Good morning, everybody. I can't believe we're still doing this, but we are. But I know you've got this, okay? We are actually going to take antiderivatives of indefinite integrals today. We've been doing definite ones, so it's going to be a little different. And the other thing that's different and weird, sorry about this, is this is from your book. So you're going to have some homework from your book. This is from 5.1 in your book. So I know on the last one I had called 5.1, it was worksheets. So sorry about that. It's the book. Anyway, let's get started. I've already pre-written these, so I got 10 examples to do. Hopefully I can do it in under 10 minutes. First things first. What's the derivative of these two? What's the derivative of 3x squared plus 7? If you said, oh, Mrs. Seta, the derivative of that is 6x. Yeah, very good. All right, what about this one? What's the derivative of 3x squared minus 5? Oh, also 6x. Interesting. So we have a problem here because when we go to take the antiderivative, how do we know what this is? How do we know that there's not a number attached? Okay, because what the antiderivative does, I want to write this down. The antiderivative does not determine a single function, but a family of functions. Okay, so you can take, you know that the antiderivative is this family of 6x, but we don't know what that extra number could or could not be. So what we have to do then is when we take the antiderivative, also known as the integral, of a function, and again, remember, this is the derivative right there. This is the derivative with respect to x. To get the original function, we call it capital F, we have to add plus c because we don't know what that value is, unless we had a point, which I'm going to show you later in an example. So after you take the antiderivative of what we're doing today, you always put plus c because that's the family. This is the family 6x plus something. All right, so the antiderivative, again, is used to determine the original function from the derivative. They're inverse operations, okay? And this process is called integration. And the symbol that we've been using and we know is the integral sign. All right, now, this is the most important rule. This is the rule you've been waiting for. You've been working on all these areas and having to do all these areas. You're like, there's got to be an easier way, Mrs. Seta. Of course there is. You know that, okay? This is your basic power rule of integration. To integrate x to a power with respect to x, all you have to do, remember when we took a derivative, we would subtract 1. We'd multiply and subtract 1, okay? Now we add 1. We add to the power, and then we divide by that exponent that we just added 1 to, and then put plus c, okay? So write that down, and we're going to try 10 problems now. And again, I've already pre-written them, so you obviously can pause this at any time. But let's try some easy ones, and we'll work our way up. Okay, so the integral of 3x dx would be, remember the exponent here is 1, so you would just add 1, so that would be 3x squared, and then divide by that new exponent, 2. And then put plus c. Done. That is the antiderivative. That's the original function. We don't know what this c is yet, but we'll find it. What about this one? What about just 2? Well, think about it. This is really 2x to the 0, right? So if you add 1 and divide by 1, that new exponent, it would just be 2x plus c. You could put a little 1 here if you want to, but it's just 2x to the 1 plus c. 9x squared. Add 1 and divide. So that'd be 9x cubed divided by the new exponent 3. Well, hey, that reduces to 3x cubed plus c. All right, what if I get fractions or radicals? Well, just like when you first learned to do derivatives, I kept telling you, try to make it a polynomial, make it look polynomial-ish. So let's make this look like a monomial, a polynomial. So I'm going to rewrite this as x to the negative 3 dx. And that now I'm going to add 1. So that would be x to the negative 2, and now divide by that new exponent, negative 2. And then obviously clean this up for me. I don't like negative exponents. So what would that be? That would be, you can keep the negative on the bottom if you want. I'm going to put it on top. Negative 1 over 2. And then this, bring it down, x squared. And then always, always, always plus c. Okay? I take off, by the way, if you don't write plus c on the quiz. All right. Number 5, square root of x. That's just x to the 1/2. Add 1. So that would be x to the 3/2, and then divide by 3/2. Well, when you divide by a fraction, you multiply by its reciprocal. So really, this becomes 2/3 x to the 3/2 plus c. All right. Next set of examples. See, we're doing these quickly. It's pretty easy. What's the integral of x plus 2 dx? Remember your integration rules, properties that say you can really take the integral of x dx plus the integral of 2 dx, and you can just do them separately. So this would already have a 1, so you need to add 1 and divide by that new exponent. This would be x squared over 2. And then this would be 2x to the 0, so you'd add 1, so it just become 2x. What do we do about the c? Well, this constant, that would be left over plus c, and this plus c, you could just call it one thing, plus c. Two constants together. So, very easy. Let's do that again. Take the integral of each one separately. So, you add 1, would be to the 5th, and divide by 5. Add 1. That'd be minus 5x to the 3rd, and divide by 3. Add 1 to the 1 already there. X squared, divide by 2. And then don't forget, plus c. All right, what if we get to this? You don't know if there's a quotient rule. You don't know if there's a product rule. So what do? Well, you make this, again, monomial looking. What do I mean by that? So you can separate this into x over x to the 1/2 plus 1 over x to the 1/2. And even then you can simplify. Okay, this would be 1 minus 1/2. Let me put my dx there. So this would be the integral of x to the 1/2. And this one I would elevator pass up, so this would be x to the negative 1/2. And now add 1 and divide by the exponent. Add 1. X to the 3/2. Divide by that new exponent. Add 1. Would be x to the 1/2. Divide by that new exponent. And I do want you to clean this up. You should know how to clean this up. When you divide, you multiply by the reciprocal. So 2/3 x to the 3/2 plus 2x to the 1/2 plus c. Okay. Number 9, we're so close to finishing. Separate this. Anytime you have a monomial on the bottom, you can separate it under each one. So this would be the integral of 2x over x to the 4/3 minus 1 over x to the 4/3 dx. Simplify that even further. This would be, what's that? 1 whole, that would be 3/3. So really negative 2x to the negative 1/3. And then move this up. This would be x to the negative 4/3. Okay. So now add 1 would be, actually, let me move this over here. So 3/3 minus 1/3 is 2/3. So 2x to the 2/3 and divide by 2/3. Minus, add 1. So add 3/3 would be x to the negative 1/3 and divide by negative 1/3. You always divide by the exponent. So let's see what happens here. Keep, change, flip. 2 divided by 2/3. 2 times 3/2 is just 3. So this 2 divided by 2/3 is just 3, x to the 2/3. This one, this is 1 divided by negative 1/3. Actually, it's a negative and a negative right here, so we can just make that positive. 1 divided by 1/3, same change flip, would just be 3 x to the negative 1/3. And then, of course, you can bring that to the bottom. 3 over x to the 1/3, 3x to the 2/3 plus c. And you should already know that these are just radicals. You can rewrite them as radicals. You could, obviously, if you want to simplify them, but I'm fine with it being written this way. All right, one last problem. Find the equation of the function whose graph passes through the derivative function 6 square root of x minus 10 at the point 4, 2. Ooh. So we're asked to find the original function. Find that original equation of the function. If we want to find an original, then we need to take an antiderivative. And what are we going to take the antiderivative of? This guy. 6. I'm going to rewrite it as 6x to the 1/2 minus 10 dx with respect to x. And I'm going to take each one of these separately. So let's see what that would be. That would be 6, add 1, x to the 3/2 and divide by that 3/2. Minus 10. It has no x, so it's x to the 0. You would add 1, you would just have x. And divide by 1. Plus c. Let's clean this up even more. Same change flip. 6 times 2/3 is 4 x to the 3/2 minus 10x plus c. Now, that's what the original function is. That's what y was. But we have this extra piece of information that is awesome. We want to know what the original function was at the point 4, 2. Interesting. So what does that mean? Well, that means that my x is 4, and my y value would be 2. So what am I going to do to this equation right here? Well, everywhere I see an x, I'm going to put 4. Oh, 4 times 4 to the 3/2 minus 10 times 4 plus c. And what does it equal? What does it equal? 2. Put that in your calculator and you will get c to be 10. So then what was my original function? Well, you just rewrite this, or actually, rewrite this one with 10. Remember, this was our function, and we plugged our x and our y point in. So our original function was 4x to the 3/2 minus 10x plus 10. That's the original function. If I take a derivative of that, I would get 6x to the 1/2 minus 10. All right, everybody. Try your homework tonight. Love ya.